Did anyone get to do any practice problems? Any of the extra practice set and drifts?
I don't think so.
Oh yeah, it was a party.
Good. Well, for assignment number 2, which is what we're going to do today, I have edited some. I know there was, I don't know if anybody did it before class, but I was going over it and there are some weird. First of all, the person who wrote it was very sassy, which sometimes I enjoy. But anyways, I've edited it to add in some information and make it a little bit more challenging, yet a little less confusing as well. So did I just upload it to the classroom? I will tell you the edited corrections I'm making along the way. Let's see. Oh, I can upload it right now, but the one that you have printed is going to be just slightly different, and not on every single problem, just a little bit, and I'm going to let you know those along the way. Let's see. Okay, save. I'm trying to make it a little bit easier for us. I did just upload the answer one for assignment 2. And even my first assignment 2 didn't have all the answers. So once we get the answers today in class, I will update that again. So look for that tomorrow. Well, let's start with happy St. Patrick's Day to everybody. And do you guys have any questions for me? How's it going so far? All right, cool. So today, I'm going to share. So last week we worked on the radar plotting transfer sheets, and we're kind of done with those now. So that was just kind of our exercise of working our triangle, working that vector triangle, and seeing that each leg is individual, right? One is what's happening actually over ground, one is what the boat is doing, and one is set and drift. And those are all 3 separate legs of the triangle. So we're going to be working that triangle on the chart in a 2-day exercise, or it's a 2-day voyage. But we're gonna do that tonight. So that's our agenda. So just as a quick review for our vector triangle, what are the 3 legs of the triangle? One, 2, 3. Can you guys see my whiteboard? I just wanted to confirm that. Okay.
Yes.
Yes.
So what are my 3 legs of the vector triangle?
Horse made good.
Horse made good. And what is attached to that is speed made good. So that's what's happening over ground. What's actually happening. What's another leg of the triangle?
Boat.
Boat.
Oh. And then the
So
current.
that's what you're steering. What is the course that you're actually steering? And then what is the speed by engine? So what is your engine putting out for speed? Which is harder to calculate by sailboat. I understand that. And what's the third leg of the triangle?
Current.
Current.
Drift and set.
Yep. Set and drift. So sometimes we're missing pieces from one or the other, but we have our 3 distinct lines, and we're going to be working with those lines on the chart today. Okay. Yeah, that's what we're going to be doing today. I know a couple of you guys just popped on. I wanted to let you guys know we're going to be working on assignment 2 today, but it is also a work in progress on assignment number 2 because I have edited and tweaked some of the questions. So kind of give me a little grace in that aspect today that I'm going to kind of be tweaking some of the answers or some of the questions, therefore some of the answers. I did upload the revised version of the answer sheet, but I will be updating that because some of them are blank, and I'll update the blank one as well. So be looking for that. Okay. Guys, ready to get started? Nice with daylight savings that's a little more light in my room here. So we can okay. I'm not going to use these. All right, so for assignment number 2, we are doing a 2-day cruise, and we are on the Long Beach chart, the San Pedro Channel. And it's also kind of a review of CoNav2, if you will. It asks us, what is the title of the chart? So where do we find the title? Trick question. The title block. So our title of the chart is going to be the San Pedro Channel. And what is the scale of the chart? Does anyone remember what scale means?
Is it the 1/80,000?
Yes, that is the scale. So, Robert, do you remember what that means? What is 1 to 80,000?
1 unit of anything is just 80,000 of that same thing.
Correct. So it could be 1 inch, 1 foot, 1 unit on land is equal to 80 units. No, 1 unit on the chart is equal to 80,000 units of that on actual land. So when we look at kind of a zoomed out or an ocean chart, that number is going to be much greater, right? Okay. let's keep going. You guys got that one. We are planning to depart Newport, so we are use that safe watermark, that NWP buoy, at 6:12, and we are en route to Edith Oil Island. So Edith Oil Island is going to be right here, kind of where all these little oil rigs are. And it's going to be kind of the closest one to shore, the closest one to Long Beach there. That is Edith. And it gives us a latitude and longitude if we want to make sure we're at the right one. But we're going to plot our DR line that we are leaving the NWP buoy at 6:12, and we're headed for Edith. So let's get a plotter. And we'll draw a line. So there's our course line from NWP to Edith. And it gives us a speed. So I'll write down the speed of 12.2 knots. It asks us what is our distance, what is our time underway, and what is our ETA. I guess it doesn't really ask us. Okay, this is something I'm going to add in then. What is the course? So,
Bree, I'm sorry, I got a quick, I'm kind of stuck here. I can't find these questions. I'm finding all the ones regarding the other chart from the East Coast, not these ones. So I'm looking through the classwork and I don't know where they are.
oh, okay. Let's see.
Aren't they on the assignments?
So we're on assignment. Let me go to classwork. Assignments week 2.
Thank you.
If you go to the stream, so you got stream, classwork, and people. If
Yeah,
you go to the stream, it's down there, set and drift, day 2 voyage, or
voyage, I got it. No, that's a, oh, that's your YouTube, no. Classwork.
So click on the ones with the answers if you're just printing it out now, because that has the most up-to-date edited version.
Got it. Okay, thank
It says
you.
revision 1 on it.
Got it. Thank you.
Yep. Okay, so we want to find the course. Did anybody find the course for this one?
I got 273.
273? Okay. Let's see, what did I get? Yep, I got 273. It's true. Gonna wait a second. Okay, so if we're using the triangle, we put our long side of the triangle on our course and the focal point on the line, on a vertical line, and we could read down at the bottom what our course is, between 270 and 280, about 3 ticks over, so 273. It also asks us distance. This is going to be more than what I can do with the divider, so I'm just going to set the divider to 5. And calculate 5. 10. 10 plus, let's see, 3.2, so that would be a distance of 13.2 nautical miles. See you guys measuring. And then it asks us, what is our estimated time underway and what is our ETA? So those are kind of steps into the same question, but when are we expected to get to Edith? So we use 60 D Street. We have a distance of 13.2 nautical miles. We have our boat speed of 12.2 knots. What is the time? So we're looking at 60 times D divided by S to give us time. What is our time?
About 65 minutes.
Yeah, I got
Yep.
an hour and 4 minutes.
65, 64. That's right. So if we left, so that would be 1 hour, 5 minutes. Excuse me, is our time. If we left at 6:12 in the morning, right? We left at 06:12, and our transit time, so this was our ETD, our transit time is 1 hour, 5 minutes. What is our ETA? I always do the minutes first. So we have 12 plus 5 gives us 17. 6 and 1 gives us 7. So we have an ETA of 7:17. So our DR here is for 07:17 to Edith. I guess I didn't put the time here. So it was 6:12. Make it a little bolder for you. Bruce, I want to check in with you. Did you get your course with the triangle or with the roll plotter?
I just did it with the triangle and finally figured it out.
Okay.
Thanks.
Yep. Okay, so this so far is what we're comfortable with, right? This is what we've done in CoNav2. We had a course, we got our ETA. That's where we're at. So now they're going to tell us we get an actual fix. So they give us a story. We encounter 00 fog. You're always prepared. You have your radar on. We have a fix at 7:17, which is exactly our ETA. Very convenient. For Edith, as a range or a distance of 1.8 nautical miles, and Eureka at 0.9 nautical miles. And then I'm also adding in here your fathometer reads. What did I say? Sorry. 535 feet. So I'm adding this to the question.
So Bree, is Eureka to our beam? Is it to the bow? 0.9 what?
So this is where we get to our 0.9 nautical miles, but we don't know where. And because it's a range, we're going to have two possible fixes, right? And that fathometer helps us decide which fix is correct. But also looking at your radar, you should kind of know, are you to the east or the west of the oil rigs? Did you already pass them or have you not passed them yet?
Right.
So that's kind of where we're adding in a little bit of, you should also look out the window kind of a thing. Okay, so I'm gonna plot these two ranges, these two distances. So I'm gonna find 1.8 nautical miles. And that was from Edith. So I have 1.8 using my little compass here. Put it on Edith. And I see I am somewhere trying to make it dark here so you can see it, somewhere along that circle. And then I have another piece of information that says Eureka down here is 0.9. So I'm going to find 0.9 on my compass here. Here's my 0.9. Oops. Okay. Well, you can see I have two possible positions. Now, given that my fathometer reads 535, which sounding would I be looking for?
So you'll be over by where the 89
Right.
fathoms are.
Yes, we are looking at this one. So hopefully we know that we haven't passed the oil rigs yet because we are this is the first time we're checking our position. That kind of means we should probably have checked our position sooner than that, but it's an exercise. So anyways, this is our actual position at 07:17. Right here. So now I am going, in order to answer the remaining questions, I'm going to complete my triangle. So our triangle has the starting point, where we thought we were headed, where we actually were. And this works because these are the same times. So I'm just going to connect my dots here. Here's a longer line. This is a little bit off for me. There we go. Okay. I can't draw that line. Anyways, we have a triangle here. So let's label our legs of the triangle again. So what is the first line we drew? What was that one?
Course.
Course make good.
So the first one was actually our heading. We were heading 273 at 12.2 knots, and it was 00 fog, so we couldn't like alter our course or see where we were going. So this was actually our boat's line. We started here and we ended up here. So this is our made good line. Does that make sense? Our intention, just going to erase that so it's less confusing. Our intention was to go from this buoy directly to Edith. And we plotted a course of 273 degrees true at a speed of 12.2 knots. And we started heading in that direction. And it was 00 fog. So we didn't really know where we were going. We just had our course and we had our speed. And then at 7:17, we used our radar to get an actual position. So this line of the triangle is our made good line. That's what we actually did. Even though we were pointed in this direction, we drifted to the south. I know you can't see the difference here because it's not that big of a difference, but we got pushed to the south, even though we were heading 273. Does that make sense? Okay, so I think it asked us, yes, what was our made good? What was our course over ground and speed over ground? Again, you could use these made good or over grounds interchangeably. So I'm gonna measure this line, see what our course over ground was. I got about 2 ticks over from 270, so that would be 268. And then I want to know what my speed was. So I'm going to measure this distance, whole distance here, on my made good line, and then use that distance to go 60D Street to speed. So I need to measure my distance. I know it's going to be over 5 or 7, so I'm going to have to walk my dividers out here. Oops. So I have 5 on my dividers. Five, 10, 11.8 is the distance that I got. So I go back to here. I have a distance of 11.8. Anybody else get 11.8? Making sure. Okay. So I have a distance of 11.8 nautical miles. I'm looking for my speed. And my time was from 6:12 to 7:17. We already calculated that as 65 minutes. What do you guys get for speed?
10.9 knots.
10.9. Yep. And we got our course over ground. We did that one. Okay, so that is the made good side of the triangle. Now I want to see what is my set and drift. What is my current? That's our other side of the triangle. So what I do is actually, just like we did on our made good one, we measure the angle and we use that distance to go back to speed. Here's my triangle. What do you guys get for a set?
I got 126.
126, yep. Exactly what I got. So as a reminder, our set is going, our current is going to. So if we thought we'd end up here, but we actually ended up here, the direction the current is moving us is towards. So I got 126. Not what would have been 306, which would be pushing me the opposite way. So current is going towards. That's how we describe the set. Opposite of how we describe wind. Okay, so we got 126 as our direction, and then we want to find the speed. So we're going to measure the distance. I have a distance of 1.8 nautical miles. Again, I'm looking for my speed or my drift. My time is again the 65 minutes. So I got a speed of 1.66. So in most of our cases here on the chart, we're not working in that perfect 1 hour triangle that we were doing on last week's assignment. So we have to do that 60D street 2 or 3 times to get what our actual speed is for measuring distance on the chart. Okay. How you guys feeling about this triangle so far? You guys following along? Okay. Good deal. Okay, so we're going to move on to the next one. So we were here at 7:17. And then they told us from our 7:17 position, you end up drift fishing for 42 minutes and find yourself right next to Eureka Oil Island. What current did you encounter? So we got our position at 7:17 and went all stops and just started drift fishing. And as we were drift fishing for 45 minutes, we drifted straight to right under or next to Eureka. Again, you're not supposed to do this, but people do. Has anyone been fishing out there? Any of you guys? No? So in this case, our triangle isn't a triangle, it's a line. Right? We had those 3 circumstances where our triangle becomes flat and becomes line. Hopefully we remember that. So in this case, this was at 7:17, and then it tells us at, oh, it tells us 42 minutes. Okay. What's 42 minutes? 42 plus 17 gives us 59. So then at 7:59, we end up right at Eureka. So we only have one line, but we're still going to label this line kind of like a triangle. So if we started here and ended here, that would make this line our course made good. I'm going to make this a little bigger so we can see what I'm labeling. So we had our position at 07:17. And then we got here at 07:59. So we went directly there as our course made good, speed made good line. What does our boats line look like? Where are we going to do our boat? Our boat was set to 0. We were just drifting. We were underway, not making way. Anyone remembers my rules? So our boat is 0. It's still staying at that point. So then I guess I'm going to do orange. The same line here is going to be my set drift, my current line. So my current is the same as my made good because my boat is doing 0. Does that make sense? That we're literally just drifting with the current, and that is the current that we are experiencing. Okay, so let's measure our line here to see what our current is. I got 195. Here it is. I have a distance of 0.9. Looking for speed. My time was 42 minutes. Oops. What was my speed?
I'm sorry, can I see how you did the triangle again to find the 195?
Yes. So I measured the line. And then it's not on a vertical because it's close to a vertical. So let me scoot this over. So then I put something along the short side of the triangle. And then you move it. Oh, I'm running into that. All right. Can you see the camera? Okay. Now I move it to this straight line. So now the focal point is on. Move my camera.
Got it. I see it. Thank you.
Okay, sorry. So what speed did you guys get?
1.14.
1.3? 1.14?
I got 1.28.
I got 1.29.
Okay. We're all ballpark. Okay. So now we are going to use this is going to be a change in our homework assignment here. We're going to use our calculated set and drift for drifting for 42 minutes to calculate a course to steer to our next position. So I'm gonna walk you through that, but keep in mind our set and drift. So from Eureka, since you've been skunked so far, you decide to head to 14 Mile Bank. That is going to be down here. Let me see. Try to focus this again. And it gives us a latitude and longitude. So we probably have this set as a waypoint in our GPS or our nav plotter as 14 Mile Bank fishing location or something like that. So we're gonna plot it because it gives us the latitude and longitude for this fishing destination. So we'll plot real quick. $23.9. This is 14.
Sorry, I can't find the 14 Mile Bank.
So it actually says Lawson's Knoll.
Oh, okay. I see that. Got it.
I don't know. Maybe it's a nickname, 14 Mile Bank. Has anybody fished that? I am not a local fisher person around here. I think that's just a local nickname people use. But it gives you the Latin long. So plot the Latin long, and then I'm just calling it 14-mile bank. And maybe if it's a place that I go frequently, I just leave that as a, marked position on my chart.
I think it's 14 miles from the jetties is why they call it that.
Okay, there we go.
It's like it's about that from glancing at it.
Okay. Makes it head that direction for 14 miles, then you'll be an efficient spot, I guess.
Shallow spot. So
Yeah.
Bree, is it fair to say too that a spot like that might affect the current quite a bit as it's shallow there as it gets you come up to about, or is that 77 fathoms still too deep to make a difference on your current?
I mean, it is definitely very deep. All of this water is very deep. But you can still get a current going through there for sure.
I just think of the current splitting around that at all. You notice that on top.
Yeah. You would. I think you would. Okay. We're going to go from Eureka. So in this question, I am kind of changing up the way that we are doing our answers here, what it's asking you. So this is one of the questions, put a little asterisk next to it, that crazy Bree here is changing it up. So I'm going to say with this is what we want to do. We want to go from Eureka straight to Lausen or whatever, straight to our fishing spot. And we are going to use the current of our 195 1.3 that we just calculated. So we just hung around here for 45 minutes or so and calculated a current. Now I'm going to apply that knowledge that I just created and get a better course to steer or a more direct route to our fishing spot. So again, this is a change in the assignment. So I'm going to label this line. This line here is going to be what we want to happen. So what we want to make good. So I'm going to label this I'm drawing sideways here. Sorry for my sloppy writing. Make good. This is what I want to make good. This line. It's the most direct route from where I am to where I want to go. Then I want to put in the other piece of information that I know, and it's going to start from the same point, which is my set and drift. So in this case here, I'm going to use that hour to make things a little bit easier for me. So I have a set and drift of 195 at 1.3 knots. So I'm using Eureka as my starting point, and I'm going to plot a line, which I'm kind of just extending my old one. But if I want to make sure it's 195, I'll make sure it's 195. from Eureka, I'm just going to draw that this is where the current is pushing me. And I know I have a drift, I have a specific end to that current line as 1.3. So in an hour, it's going to push me 1.3 knots. So I'm going to find 1.3.
Wow. Okay.
Make this a little bigger. So I have an end of the line here. So I have my triangle starting to form. I have my start point, my made good, but I don't know what my speed made good is going to be. And my set and drift line. I know my set and drift is pushing me towards 195 at 1.3 knots. So similar to our homework questions, right? We did a couple practice ones of these. And then to clarify, our boat speed, it tells us in the problem, which I'm going to make sure it clarifies here, our boat speed is set for 10.7. Oh, this is why we didn't do it, because our dividers don't go to 10.7. If you have other dividers that do go to 10.7, actually, you guys have a triangle or a roll plotter, right? There is a distance scale on our triangle roll plotter. This only works if you are in a 1 to 80,000 scale. And we checked at the beginning of our homework assignment that we are in a 1 to 80,000 scale, right? So I'm going to start from 0 and find my 10.7. So I'm putting my 0 on the end of my current line. Okay, you can see why I made up this problem and now it's not working out as great as I wanted it to. So if I started on that line and I go 10.7, this is a little tricky. I give you that. Here is 10.7. So just before, for me, it's just before that that waypoint that we're going to. I'm going to change this. Let's see. I'm going to change it to. Okay, so here is the end of my line. Now, if I connect these two, this would be my boat's line. And we want to do a double check. Does this make sense? I want to make it this, but the current is pushing me in this direction. So I want to steer into the current. Makes sense. Did we calculate this course line yet? I didn't write it down. We didn't write it down. Okay. Let's calculate what we want to make good, or measure what we want to make good. Uh, 148. And now my boat line
These guys did all this shit.
is 144. So that makes sense. And this distance, or this speed, was 10.7. That's what my boat was doing. This is my current triangle, and this is my made good line. So in order to get a ETA, or a time run distance, I need to calculate what my speed made good is going to be. What is my speed made good? So using the same hour line, so right before my fishing point here, I'm going to get 5. Calculate the distance. 5, 10.
I'm fucking lost.
10.5. So not too big of a difference of speed. It was 10.5 nautical miles, and because this is an hour triangle, 1 hour, I can easily convert my 10.5 nautical miles to speed. So
What did you use to calculate the speed, Bree? How'd you get the 10.5?
I measured this distance
Right.
to the end of the triangle that I made. So this distance was 10.7 because that was my boat speed.
Right.
So the
So
distance.
the bottom line was 10.7. Okay.
Yes, this one is 10.7. That's what my boat is doing.
Right.
So to measure this one, that's what my speed made good would be.
But isn't that longer? How can it be 10.5?
That is longer. It's 11.5.
11.5. Okay, that's what. There we go.
Okay, thank you.
Sorry,
Okay.
sorry.
I know it's crazy there for a minute. All right.
No. I was like, I measured it. 1.5 plus 10, it's 10.5. No. 1.5 plus 10 is 11.5. Sorry. How are we feeling on this triangle?
So the radar plotting sheets were pretty much for practice. We don't need them tonight. We don't need any more.
Correct. Correct. They were just a practice of conceptualizing this triangle.
Okay.
So we're putting those skills to the chart. So the difference between, I don't think my camera is going to be able to show us these two triangles. Maybe it will. Anyways, the difference between these two triangles I want to talk about. This one, we started with what our boat was doing. We plotted a course and we just started steering it with our set speed. And then we calculated a position, and then we calculated what actually happened in the past. So we thought we were on here, but we ended up over here. So I got my made good as in a past thing, kind of which came first, the chicken or the egg. Like these are kind of two separate things here. So in the past, we got our made good and we calculated what the current was. And this triangle down here, we had what we wanted to do. We want to make good this line. And I have a known current. I've calculated the current. So I want to know what to steer. The question is, what is my boat line? Where in this triangle up here, I had my boat line. My question was, what is my current? So we still, label each line that, we know what our boat is doing. Then we have what's happening over ground, whether it's in the past or in the future, and our current line. So I just want to distinguish between, there's the same type of triangle, but we went in with different information. But we're still creating those three lines, that boat line, the made good line, and the current line. Okay. How are you guys feeling about this? Okay.
Shaky.
And when you use the terms speed over ground and course over ground, that is the boat line or the made good line?
That's made good.
Made good, right? Okay.
Yeah. Okay, let's take a breather here. Let's take a 5-10 minute break and come back at 10 till. 10 to 8. You guys good with that? All right. Ted and Warren, are you guys there?
Yes, we're here.
Cool. I wanted to show you, one of you guys asked last week about why there are mixed tides versus semi-diurnal. And I was trying to do some research on it, and I found a lot of solar versus lunar tides, so tides driven by the sun or tides driven by the moon. But I did find a little explanation on diurnal tides, and because of the axis of the Earth, how we have some different versus, northern Atlantic, the east side of the northern Atlantic versus the east side of the Pacific, which is us, don't have that same mixed tides, kind of with the axis of the Earth, and that is why there are mixed tides. So there's a little handout. I uploaded it onto the Google Classroom if you are more interested in reading about it. So hope that helps. I don't think it answers all of the questions behind it. I'm
Thank
still
you.
trying to look for some more information, but I wanted to show that to you. Cool. Okay. Well, let's new share back to this. Okay. Okay. So where were we? We were fishing for many, many hours. Many, many hours fishing around our 14, oops. Our 14-mile bank. So we have been cruising around all around here, fishing, not really plotting our position all day. Hopefully avoiding traffic in the traffic lanes, not fishing in the traffic lanes, etc. But we don't know. So we're probably here around 9 o'clock. And then we get our next fix at 18:15. So we are in a whole other area. What is that? 9 hours later. So we want to plot our 18:15 position. So I'm going to do that real quick. 5, 7. And 18.4. So we are way down here. At 18:15. So we had a big chunk of the day missing, right? We were up over here around 9, and then we ended up here at 18:15. So we went somewhere along the way, but don't really know where. But we're here at 18:15, and we decide because we have not caught any fish yet, woe is me, we're gonna head back to Catalina. So we head for Long Point. So we're gonna plot a course from our 1815 position. Sorry. From our 1815 position to Long Point up here. So we're going to create a track line. Hopefully we can see Long Point. I need a longer line. So I plotted a course. Oh, I'm on the second page. And it asks us, what is the course? Let's fill in the blank here. We reduce our speed to 10 knots because it is dark and we know we should reduce our speed. Okay. So let's get our course. .297 at 10 knots. Okay. So we have at 1841, we are going to plot our position using some bearings. I am changing these bearings to bearings true and not in that relative form. I don't think you can get very accurate relative bearings, and I feel like this is just testing knowledge that we've already practiced this in Coastal Nav 1. So I'm going to give it to you in true. You could write it down. We have a sorry, hold on. I put it up here. I'm going to say we have at 1841, Long Point is bearing 302 degrees true. Light 2, so that that light off of Avalon is bearing 282 degrees true, and we lose sight of east end light. So this is our position at 1841. So we're going to plot where we are at 1841. I've changed these numbers a bit from the assignment because the assignment gives them to you in relative, which is just extra confusing. Can everyone see that? Okay. So we're going to plot those bearings. We have long point at 302. I'm just going to draw this line so I can see it. So long point, I'll put my pencil on long point, my triangle on the vertical, and find 302. There is 302. So I will actually, no, I'm going to have a little bit longer line than this. So I'm going to move my triangle a little bit down. And get an LOP there. So I'm somewhere along this line at 1841, and I have another LOP to the light 2. So we have 2 lights at the entrance of Avalon. We have one, which is to the south, and then 2, which is on the northeastern side of the entrance. So we can see it's in quotes there. Right here is 1, right here is 2. One is green, one is red. Looking for the red one. Okay, so I'm going to put my pencil on that light, and I'm going to find 282. There's 282. Again, I'm just going to extend my line a little bit so we can get across. 1841. So I have an LOP from light number 2, an LOP from long point, and my third thing says I lose sight of east end light. So that is the light down here, and it gives me this light obscured. So I could use that, and I want to say you can use that, but not like. I want to say that this light obscured line isn't as accurate. I might not use it as like a strict LOP, maybe just as a check to make sure my other LOPs are right. Because maybe you're seeing the light bend a little bit. I don't know. That's just my opinion. So we have these 3 lines crossing right here at 1841. Everyone get an 1841 fix? Get your lines to cross? Maybe? So I want to plot that, make sure I have it right. What is the latitude and longitude you guys got? Practicing our plotting. I'll do this one first. Two, so I got all right. So we got our position. We're gonna start building a triangle. Call me crazy here, but that's what we're doing. Okay, so it asks us then, what was the current? What did we encounter from 1815 to 1841? So I do want to answer before we get there. So this is what I was doing. And then at 1815 to 1841, I've obviously drifted off my course line, right? So if I connect this, let me erase this line, shorten that up. This is my made good. This is my boat line. So how do I put in, how do I see what my set and drift was, what my current was? Any guesses? How do we finish this triangle? We plot a DR. Remember that DR is what our boat is doing. It's just our course and our speed from our boat. So if we were going along here at 279 at 10 knots, but we ended up over here at 1841, what is our DR for 1841? I haven't calculated that yet. So 1815, where do I think I would have been at 1841? I have to do some math. $18.41 minus $18.15 gives me 26 minutes. My speed was 10. Oops, 10. My time is 26. What would have been my distance traveled? .3 nautical miles. So I'm going to plot my DR. So from, again, this is my boat line, and this is my made good line. My triangle, or yeah, my whole triangle here is a, 26-minute triangle. So the difference between this DR and my actual position, DR is calculated from our boat's heading and our boat speed to our actual position. That's going to be our current in 26 minutes. So what was our current? See if I can measure that. Push me towards south, so I got current of 221. Is that making sense so far? So then I want to calculate what the speed of my current is. So I'm going to see what my distance. Here's my dividers. So the distance the current pushed me in 26 minutes. I got a distance of 0.7. I'm looking for speed. How fast did it push me? The time that it took to push me 0.7 nautical miles was 26 minutes.
.6 knots.
4.6 knots.
Correction, 1.6.
1.6, yes. I was like, that's really fast. Yes. Make sure I do it right too. 0.7, 60. Yeah, 1.6. 1.6. So I have a current of 1.6 knots pushing me towards 221 degrees. That is my current that I encountered from 1815 to 1841. Trying to get everything on the screen here. So again, we made our little vector triangle. All right. Any questions with this vector triangle? Okay. So then we decide to head for Avalon, right in between buoys 1 and, or the lights 1 and 2. What is our course from our 1841 position? What is our distance? What is our course? And what is our ETA? And then it gives us a little pro tip to use our ETA from our made good speed, not our boat speed. So have we calculated our made good speed yet? We did not. We calculated what our current was doing. We calculated what our boat did, but I haven't done my made good yet. So I want to see what my made good speed was. So first thing to do that is measure. One, two, three, four. Here. So my speed made good. I have a distance of about 4.5, 4.55 maybe. I'm looking for my speed. My time was 26 minutes. Speed is about 10.4 knots. Did you guys get 10.4? Okay. Okay, so if I am now headed to a spot right in between entering Avalon here. Here's my 41 fix. Right there. Again, they don't really give us a destination. We're just kind of doing it right there on that 16 sounding, if you will. So let's see, what is my course? Course is 282. And my distance My distance is 5.4. Erase this. If I have a distance of 5.4 nautical miles and my speed made good is about 10.4 knots, what is my ETA, or how long will it take me to get there?
Thirty-one minutes.
Thank you for doing my math. 31 minutes. So we have 1841 plus our 31 minutes. $72, that doesn't work. So we carry the 1, 12, 1912 as our ETA. ETA to Avalon, 1912. Just this answer sheet. Does anybody have any questions on that so far? Okay, so we have set. Okay. So we stay the night in Avalon. And then on day 2, we start to get underway again. Here's my day 2. Here's my day 2. Okay, so for day 2 assignment, I have deleted all of the parts of the questions where it gives you your deviation and your variation. We should be able to figure out how to get deviation and variation on our own by now, right? We're going to use the deviation table, and our variation is found on the compass. So don't trust what they give us, because I found them to be wrong. And calculate it using the deviation table. Go ahead and get started on that. I need to go to the bathroom real quick, so I'm going to take a 5-minute break. Feel free to take a 5-minute break if you need to, but I will be right back.
Which one? I'm just trying to figure out which, if I'm good. What's that first question?
So day 2, we're going to depart Avalon and head on a course of 347, and it asks you what your compass heading is. So that's a straight compass question.
Okay, I'm just trying to make sure I got the right page here, the new page, not the old page.
Oh, okay, yeah. Okay, I'll be right back. just don't give me a second. Okay, I'm back. Sorry about that. Okay. Let's get to it. All right. Move my monitor. Okay. So on day 2, we leave Avalon and we are on course of 347. So I'm just going to plot a course 347 from Avalon. Okay. Is this going to work? All right, so it looks like we're headed up north around Long Point. Plot 347. So I leave Avalon and head straight for 347. And it asks me, there we go. What is 347 per standard compass? So TVMDC, we're remembering this, right? Our true was 347. Variation we get from the compass rose. 12 east. So going down T to C, are we adding or subtracting east?
Subtracting.
Subtracting east, adding west. So we're going to subtract that 12 and we get 5, 3, so sorry. 335 degrees. Magnetic, and then we go to our deviation table. We find 355. 335, excuse me. 335 is going to give us 1 west as our deviation. 1 degree west. We're going down still, so we're going to add that west, and we get a compass of 336 PSC. So that's just a little refresher, but we remembered how to do that, right? Okay. Then it told us when Long Point is bearing 270 relative from us, and light 2 is 180 behind us, what is our position. So with this, I'm just going to use the triangle. And I pretty much, went through or went right next to the buoy 2 or light number 2 on my way out. So I'm gonna kind of, anyways, let's do the beam one first. So 270 is directly a beam, right? 270 degrees from the bow. So I'm going to use my triangle and line up the middle line of my triangle on my heading line. And then I'm going to see where it passes, where I would be a beam of long point. And that is going to be at 0900. And my buoy 2 is right behind me, relative bearing astern. Dead behind me. So I could use my heading, but it goes right through that there. So this is my 9 o'clock position. And it asks us to get the actual position. Okay. So my position, I'll just write it in here, was $24.7. So I got 33, 24.7 north, 118, 20.4 west. So this is my 9 o'clock. Then it told us at this point, we decide to head for LA Harbor. So we're going to go up to LA Harbor and head for buoy 1. So let me just adjust my camera here. think I'm gonna do this in 2 parts. So we're gonna find our LA buoy 1. So that's this guy right there. So this is our Long Beach side. This is our LA side. They give us a position. No, they just tell us flashing green, 2.5 seconds on the LA side. So I'm going to make a course from this buoy in my 9 position. Okay, so let's see if I can fit. One more thing. Barely reaching. Okay. So this is also where I changed the assignment a little bit. I'm going to give you a set and drift for this area. Let's see. Revision. So I'm going to calculate my set and drift using my tidal current tables. And I have a given set and drift of 110 degrees at 1 knot. So what is going to be my course to steer and my boat speed? Add this in here. My boat is going to be going 15 knots. Okay. Okay, so I wrote this up here. My current is 10 or 110 at 1 knot. My boat speed is 15, and I want to go from my 0900 position right here up to buoy 2, or buoy 1, excuse me, buoy 1. So I'm going to move it down here a little bit. So let's define our triangle, right? That's what gonna want to make sure we have a good triangle. So here's our 0900. This is our starting point, if you will. And we have a current of 110 at 1 knot. So I need to create that current. So it's going to be pushing us down the channel at 110. And I want to go from where I am to buoy 1. So this line that I've already created is what I want to make good. So I'm going to call this my made good line. So I need to create my boat line. And I know that my boat is going to be at a set speed of 15 knots. So let's get started drawing our triangle. I have a starting point. I have my made good line. I'm now going to draw in my current, my 110 at 1 knot current line. Erasers. So I'm going to find 110. Here's my direction of 110. Now, I know from the previous question and my plotting that in order to make my boats line of 15, I cannot do that with my triangle or my dividers. So any ideas of how we can make our triangle smaller? Let's make it a 30-minute triangle. Let's just cut it in half. Shrink the triangle a little bit so we can use our dividers. So when I draw my lines, I can use 60D Street, but because I know I'm just cutting it in half, making it a 30-minute line instead of a 1 hour line, I'm literally just going to cut these numbers in half. So my distance on my current line is going to be 0.5, half of 1 knot. So in 30 minutes, it's going to push me half a nautical mile. Does that make sense? Okay. Make it half. So again, I'm making my triangle instead of the hour, I'm making it 30 minutes. You can make it whatever size you want, right? But 30 minutes is more manageable for me and my nav tools than the simplicity of doing it on the hour. So I have my current line. I have my made good line. And then I want to put my boat line in there. My boat speed is 15. So in a half hour, what would my distance be? 7.5. So I'm going to find 7.5. So I have 7.5 on my dividers, and I'm going to start that at the end of my current line here. So now I can create a boat line. You guys with me so far? Okay, so I want to know what is my course to steer. So if I want to make good this, my current's pushing me this way. This is my calculated boat course. So I want to measure that. 018. 018 degrees true is my boat line. We'll see what my made good line was. I'll just write it in. Zero to 1 degrees. Okay. So I would be wanting to make this good, 0 to 1. The current is pushing me this way, so I'm steering into it at 018. Just 3 degrees, not much, but that's going to be the course to steer so I can make good this line. So even though we didn't, draw this line all the way across the chart, we made it a short triangle on the half hour. And we got our course to steer. So our course to steer is 018. It asks us what our ETA is. What is our ETA up to this point? So we need to use our speed made good. So we need to measure our speed made good so we could get an accurate ETA. So let's measure that speed made good. By looking at it, I can see that my current is pretty much on the beam. So it's probably not going to affect my speed that much, but let's measure it. See if my guess is accurate. I got 7.5. Maybe just a hair shy of 7.5, but I got 7.5. So remember, we're gonna double that, put it into our 60 D street, and just that quick math is going to be my speed made good is 15 knots. Does everyone get how I had 7.5 nautical miles and I moved it to 15 real quick without going to 60 D street? I don't want to like rush over that if it's, I understand I'm making some shortcuts here.
I just grabbed a yardstick off the wall and used and drew the full line. I didn't do
Oh,
that
there you
after.
go. Okay. Okay.
Wouldn't have that on the boat with me, most likely, but
You know, it's always good to have a yardstick on the boat because sometimes you're drawing big long lines. Okay, so I want to figure out my ETA still. Oh gosh, move it up here. So I have my speed made good of 15. And I want what my ETA is. So I need my whole distance of the whole leg here. So I'm going to measure 5. And walk it. So from our 9 o'clock, we have 5, 10, 15, got 15.9. So I'm going to use my 60D street. A distance of 15.9. I have a speed of 15 knots. What is my time? Pretty close to an hour, but a little bit more. $63, $64, I'll call it 64 minutes. So my ETA, 0900 plus 104 gives me, can't do math, 10:04.
Hey, Bree, I got a question on speed.
Yep,
Okay, so the speed that you're reading off your knot meter is not necessarily, I mean, the speed that your knot meter is reading has current involved in it. So the speed that you're actually reading off your knot meter, maybe if you've got, say, a 1 knot current coming towards you and your speed on your knot meter says 15 knots, you're actually going, 14 knots.
14,
right?
yeah.
Yeah.
Correct. This just works out to
You
15 and our
calculate-
boat speed was 15 because the current was right on the beam.
Yeah, so these speeds that you're talking about, are these speeds that you're reading off a knot meter, or where are you getting these speeds from?
So the one that's coming from your knot meter. So let's do a triangle. Exaggerated. So if we think we're going along and we have the currents coming this way at 1 knot.
Yeah, just keep it simple.
Instead, keep it simple, right? So if we are underway and our boat is doing 15 knots, that's what the speed through the water is, essentially.
Right.
So
Your actual speed is 14.
your speed made good. So your speed made good would be 14, even though your boat is chugging along, whether it's propeller or speed through the water, at 15.
Yeah.
So your speed through the water goes on your boat's line.
Yeah. All these speeds that you're referencing in our calculations here are these speeds that are adjusted for the current. So there's speed made good, speed over ground.
Yes, your speed made good is the one over ground. Now, sometimes your fathometer, depending on what tool instrument you have on board measuring speed,
Yeah.
it can be set at speed through the water, or it might have this BT light or button that's illuminated, and that means it's bottom tracking.
Yeah. Okay.
So if it's bottom tracking to calculate your speed, then that speed is speed made good.
Got it. Okay.
Did that make sense?
Okay. That makes sense.
Okay, everyone else kind of follow that? Okay. Okay. We are almost done here. Good, we got 25 minutes left. We only got one more triangle to do. A lot of triangles today. Okay, so let me move this up here. My cord's in the way, but you can figure that out. So it tells us after the long haul, we go for a little cruise. We enter LA's harbor. We cruise around Cerritos Channel, so that's back around Terminal Island. And then we come out the Queen's Gate, so that's over here. So it's asking us, we head straight out Long Beach Channel to the Long Beach Light and head for our LW buoy. So that's our safe water mark. We've used it in the past here. Our LW safe water mark. And it is asking us what these abbreviations mean. Anybody? What color is the buoy?
It's red and white.
Red and white. Is it horizontal or vertically striped? It doesn't tell you on the chart. This is the
Doesn't tell
quiz.
you.
Those are vertical, aren't they?
Vertically striped. Yes, our safe water marks are vertically striped. So it's red and white with vertical stripes. It has an LW on, or an LB, excuse me, an LB on it. And what does that MOA mean?
Morse code.
Morse code A.
So what is that describing?
The light flash.
The light
Yes.
flash.
The light flash. And what color is our light?
It's white.
It's white.
It's white. It doesn't tell us on here, so the default is white. It's not going to tell us the color of the light, then we know the light is white. Tongue twister. So then it also tells us it has a whistle, and then it tells us it has a raycon. That long, short raycon. I was going to show you the raycon. Ask me at the beginning of next class. I want to make sure we get through this assignment because I changed it of what the raycon looks like. But I'll show you at the beginning of next class. Show raycon. Okay. Okay. So we're going to go from this buoy and head back to Newport to our NWP buoy. So again, pop quiz with our NWP buoy. What do all of these lights mean? Same thing, it's a safe water mark. So it's vertically striped, red and white. It has, so you can't see it down here. Our NWP buoy down here has our NWP on it, and it says MOA. So that's describing the light abbreviation is Morse code A. That's long, short, long, short, long, short. Okay, so we are going to be going from LW why do I say LW? Long Beach buoy to the NWP buoy. And from this, or from past experience, we have a set and a drift. We depart at 1500 or Long Beach buoy. What is our course to steer and what speed is needed to arrive at 1630? So in this case, we are looking for what speed the boat has to do. So we're going to draw our triangle. So we can all get started on that. But we want to know what course to steer and what speed our boat needs to do in order to make an ETA. So we have a desired speed made good. We haven't calculated that, but in so many words here, we're going to leave here at 1500 and we want to arrive here at 1630. So that is giving us a desired speed made good that we need to calculate. So I'm going to get started with plotting it here. I'm going to have to adjust my camera. So bear with me. Okay. There we go. Okay. Is this crooked? Okay, so the line that I just drew from Long Beach to Newport is the line that I want to make good. Then it tells me I have a set and drift. From this, I know set and drift is typically 0.70 at a drift of 1.7. Okay. Let's see, what am I going to do first? Okay, actually first, I'm going to calculate my made good. I'm going to see what my made good course is and what my made good speed is. So here is 1500 and here is 1600. So that gives me a, where am I at here? A time of 90 minutes, a distance, and I'm looking for speed. I'm looking for what my speed made good is. So I want to see what the distance and the course of this made good line is. I think we've done our course a few times. Write that in. 112 degrees true. The distance, I have 5, 10, 15, 16.6. I have a distance of 16.6 nautical miles. Oops. Oops. So what is my speed that I want to make good?
11 knots.
11 knots.
11.1 by 11.
We're going with 11? Cool. Okay. So, from my past experience on this page, my dividers will not reach 11 knots. So I'm going to write this in. My speed made good is 11 knots. Yes. So I want to cut that in half in order to make my triangle, my vector triangle. This again is my quick way of making that triangle because it might be too big. Actually, I'm wrong. And now that I'm saying that out loud. My triangle, my dividers here, don't have to do 11 knots because my speed made good is 11 knots, not my boat speed.
Right. Your drift is 1.7, we said?
Yes, 1.7. So I actually am going to do an 11 knot DR and do this triangle on the hour. Does that make sense?
Mm-hmm.
Because this is the line that I want 11 knots and it's already drawn for me. So I'm going to find 11 on my, so I'm going 5.5, make it a little easier for myself. So this, I put it as a DR line, but this is where I want to be at 1600. But I don't want you to get this confused with my boats line. This is still what I want to make good happen. 1500 here, 11 or 1600 here. That's a distance of 11 nautical miles.
1 hour.
Then I'm going to plot my current line of 1.7. I can do it with my left hand. Okay. So this is my current line of 1.7 knots at 070 degrees. This is my made good line at 121 degrees at 11 knots. So if I connect these lines, if I connect these lines, that is my boat line. So my desk becomes a mess in this class. Okay, so I want to make good this, and the current is pushing me to 070. So I'm going to steer into the current, and that is the line that I've drawn to figure out what my course to steer is. This is what I'm going to get my course to steer and my speed by engine. So as I'm doing this, I'm steering whatever my boat line is, not my made good line. So let's measure my boat line for boat speed and for course to steer. My course to steer I got was 120.
So Bree, this current is pushing you towards the shore?
Correct.
Yeah.
It was a current of 070. 5. So I got a speed of 9.8 knots. That was my distance of 9.8. And this is on the hour. So my 9.8 distance is equal to my 9.8 speed that I want my boat to do. Okay. That was a lot of work we did tonight. Where are you guys at? How you feeling?
Do you need to make adjustments for speed due to the depth of the water there?
You could. That's just gonna complicate the question a little bit more. But again, hopefully along the way, you're plotting your position every 30 minutes or so and adjusting. That you're not just setting and forgetting, which some people do. But tried to make it a little simple, even though it was very complicated. Let me bring you guys over here. Let's see. Okay. So this was a lot of work and I adjusted the homework assignment. So I will be posting the revised, edited version of the homework assignment blank and answers tomorrow, and the recording of this class. So look for that. Next week, we are going to be doing we are not going to be doing any chart plotting. We are doing all tide calculations. So tide and current calculations. This is the 2021 tide tables. You don't have, if you have this, have it out. If you don't have it, don't sweat it. There should be a copy of the LA and San Diego chart tables in your handout. I've also put that up on the Google Classroom. I think that's it. That's what you got there, Robert, the handout. So that's what we're going to be using. So tomorrow, or not tomorrow, next week's class is all going to be about calculating. We're going to focus on tide, but it's similar, slightly different, but similar steps into calculating your current. So the currents we use today, some of them we calculated by the difference between our DR position and our actual position. And some of them we were given, and how we would be given them is by using our current tables, our tidal current tables, or an app, or whatever website prediction method that you use. But that is what we're going to be going over next week, is calculating things by the book. So it's not going to be any chart work, but we're going to do tides. And then the final week after that is kind of an exercise where we do kind of a circle around San Pedro again, kind of like we did today, but it's more on voyage planning. So we're given a tide for the entire, or current for the entire area, and we're plotting our course to steer for that. So that's pretty much it. Let me know if you guys have any questions. I'm actually going to be out of town this weekend, so I won't have my document camera, but feel free to call me. But I can meet up Friday or any of the other days if you want to do another Zoom to clear up some things. But that's all I got for you. So no real homework this week because we just did it in class, but the more you practice, the better you'll be. So that's all I got for you. Any questions from you guys? All righty. Well, happy St. Patrick's Day. And have a good weekend.